Hello everyone and welcome back to Newton's Academy past paper review for grade 12. Today we will be doing a mathematics past paper question and that will be on the topic of trigonometry, question 8. So let's get started right with it. Question 8.1 tells us if sine A equals 3 over 5 and cos A is less than 0, then determine without the use of a calculator the value of sine negative A and tan A. So the first one is quite straightforward because it's given to us in terms of sine, which is something we are already given in the question. So we need to determine this expression in terms of sine with a positive angle. So we can go ahead and use our Cartesian planes rule. Sine negative alpha is in the fourth quadrant. Sine is negative in the fourth quadrant. So therefore, sine negative A will be equal to negative sine A. And we already have the value of sine A being equal to 3 over 5, so we just substitute that in. Therefore, that will equal to negative 3 over 5. And that is our final answer. Okay, looking at question 8.1.2, it asks us to determine the value of tan A without the use of a calculator. So for this question, there is slightly more required. Obviously, we are only given sine A in terms of a numerical value. We are not given tan A or cos A. So this will require us to draw a Cartesian plane. So there's two requirements when determining which quadrant to draw your triangle in for the Cartesian plane. So you have to sort of form a checklist and have two checks in one of the quadrants in order to let you know which quadrant you're going to be drawing your triangle in. So let us go through that process. The first part of the question tells us that sine A is 3 over 5, meaning sine A is positive. So we know sine is positive in the first quadrant and in the second quadrant. And then our second indicator told us that cos A is less than 0. And we know cos A is negative or is less than 0 in our second quadrant and in our third quadrant. And as you can see, we have a double check in the second quadrant. Therefore, we will draw our triangle in the second quadrant of our Cartesian plane. So let's redraw a Cartesian plane here quickly. Just a rough sketch. You draw your hypotenuse and always connect your hypotenuse to your x-axis. We know sine is opposite all over hypotenuse. Therefore, our opposite side is 3. Our hypotenuse is 5, and that is our angle A. Why? Because A is always the angle from the positive x-axis to our hypotenuse in an anti-clockwise direction. Now, in order to determine tan A, we know tan is opposite all over adjacent. We do not have our adjacent side, so we will need to calculate it. That can be done quite simply because this is a right angle triangle. So if we use Pythagoras, let's call this x squared. X squared, this side will be x, is equal to 5 squared minus 3 squared, and we will get x to be 4. However, x we can see is on the left hand side of our y-axis, therefore x will be negative 4. Just an indication, when determining your trig ratios, we take it as if A was that angle there, but in reality A is that exterior angle. Okay, so then we can quite easily determine the value of tan A because we know that tan A is opposite all over adjacent. So therefore tan A will be equal to negative 3 over 4. Okay, moving on to question 8.2. Question 8.2 tells us if cos 34 degrees equals P, then without using a calculator, write down the following in terms of P. Okay, this is a very common question that comes out. They give you a trig ratio in terms of an alphabet, then they'll give you other trig ratios and tell you to determine it in terms of that alphabet. So what you have to do is you have to find a way to express these trig ratios in terms of that angle or of the co-function of that angle, meaning if you have to draw your right angle triangle out, there will be another angle when you subtract this from 90, or from when you use sum of angles in a triangle, and then you will get that angle. So you need to determine it in terms of one of those two angles. So you follow a step-by-step checklist again. You either see if you can determine that angle in terms of your reduction formulae, in terms of co-functions, then you turn to your right angle triangle, and then lastly you can look at double angles and compound angles. Okay, so for 8.2.1, cos 214, we said the first point on our checklist was to see if we can find that angle, which is the angle 34, in terms of reduction formulae, and we see that that is possible. Why? Because cos of 214 is equal to cos 180 plus 34, and we know that cos 180 plus is in the third quadrant, and therefore that will be a negative. So negative cos of 34 using the reduction formula, that will, therefore we can now go substitute p where we see cos 34, and that will give us a final answer of negative p. Okay, question 8.2.2 asks us to determine cos 68 in terms of p. Now when looking at cos 68, we see that we cannot really find it in terms of the angle 34 using reduction formula or co-function, etc., etc. And even using our triangle, if we have to draw our right angle triangle, there's no angle of 68 in there. So then we have to turn to the next best thing, which is either compound angles or double angles. And we will realize very quickly that in this question, we can determine 68 in terms of double angles. Why? Because cos 68 is equal to cos 2 times 34, and that is a double angle. So we can choose which double angle we want to use. The easiest one would be to use 2 cos squared minus 1. So 2 cos squared 34 minus 1. Why did we use that? Because we already have cos 34 in terms of p. It wouldn't make sense to go use sine. That would create a lot more work for us to do. So therefore we know that cos 34 is p, so that will be 2p squared minus 1. And we have successfully determined that expression in terms of p. Now the last expression asks for tan 56. Now whenever you are asked to determine tan of an angle in terms of p, that will usually require you to draw your triangle, because you would have to complete the sides of your triangle and use the opposite and adjacent sides of your triangle to solve the question. So drawing our triangle, we know we have a right angle triangle. Okay, so we have one right angle, we have one angle 34, and filling in the last angle using sum of angles in the triangles, we see that we get that to be 56 degrees, which makes our life easy, because we know if we want the tangent of that angle, we simply have to determine the opposite side all over the adjacent side. And based on the fact that they told us that cos 34 equals p, we know cos is adjacent all over hypotenuse. So we know p is the adjacent side, and we know that there is a 1 there. We can always divide it by 1 because it doesn't change anything. That will be our hypotenuse. So our hypotenuse will be 1. Our adjacent side, remember in relation to the angle 34, is p. And completing our opposite side in terms of that angle, we can use Pythagoras, and we will get that to be the square root of 1 minus p squared. Okay, so now we have all our sides filled in. So now if we want to determine tan of 56, it's quite straightforward. We simply need the opposite in relation to the angle 56 over the hypotenuse. So our opposite is obviously the side which equals to p, and I mean opposite all over adjacent, sorry, and our adjacent side is the square root of 1 minus p squared. And our expression is in terms of p, so we can, that will be our final answer. Okay, moving on to question 8.3. The question says, without using a calculator, determine the value of the following expression. Cos 350 multiplied by sin 40 minus cos 440 multiplied by cos 40. Now we can see that we have two trig ratios multiplied on each side, separated by a minus. So usually in this case, it means we are going to form a compound angle. So we have to simply use reduction formula or all our identities and trig rules to simplify this expression so that we can form a compound angle identity. So let us get into that. 8.3. So cos 350 is what we had initially, sine 40, cos 440, cos 40. So let us just write that down first. Okay, cos 350 multiplied by sine 40 minus cos 440 multiplied by cos 40. And now we have to simplify this using our reduction rules. So this can be simplified to cos 10. Why? Because that can be written as 360 minus 10. And 360 minus is in the fourth quadrant, cos is positive in the fourth quadrant, therefore we get cos 10. Sine 40 does not necessarily have to be simplified further. For now, we can see where this goes and where it takes us. Cos 440 again is simply 360 plus 80. So this can be written as 360 plus 80. We know that 360 plus is in the first quadrant. Cos is positive in our first quadrant, so that just becomes cos 80. Okay, and cos 40 we can leave as is. Now looking at this expression, we see that we have cos and sine, and then we have cos and cos. But there is no compound angle identity which in the one term has both ratios being cos, and then in the other one cos, one is sine. So we have to either change this to sine so that we have two sines and two cos, or we have to change one of these cosine ratios to a sine ratio so that it becomes the same as the angle in one of these angles in the initial term. So the easiest way to do this would be to leave the first term as is. Why? Because we see that we can form quite a nice sine compound angle ratio when we change this using cofunctions. Sine 10, why? Because 80 is the same as 90 minus 10, and that becomes a cofunction to give us sine 10, and that is cos 40. And we see that this forms quite a nice sine compound angle because we have sine cos, and our angles are the same in each term. Okay, so we can go ahead and use our sine compound angle identity. We see that it is separated by a negative, so our two angles will be separated by a negative, and that will give us sine 40 minus 10, because those are our two angles. Obviously, if you wanted this to be written out in a easier form that was easier to see, you could have simply written it as sine 40. You have just rearranged it, cos 10 minus cos 40 sine 10. We simply rearrange the terms. That's if you couldn't see your compound angle in this expression. And once you have that, you simplify this. This is to become sine 30, and we know sine 30 is a special angle which equals to a half. And we have now calculated the value of this trigonometric expression without using a calculator. Alright, so that brings us to the end on this question on trigonometry, and thank you for watching.